What's up, everybody? Welcome to Today in Space. We're rocking our new Today in Space jacket. We'll be getting some official patches on here of some of the missions we've been following over the years that we have patches for. But also, we've got brand new merch out. If you haven't heard, the Starship 3D printed rocket pen is out on our Etsy store, ag3dprinting.etsy.com. It's 3D printed by us. It was designed by us, influenced obviously by SpaceX's Starship, but not officially anything to do with SpaceX. But it's an amazing piece of merch that we're making here in our lab, AG 3D Printing, and it's available right now. $65 out on our Etsy page. Pretty comparable, especially with the space pen that NASA has at their merch store. So a great gift for the space nerd in your life or yourself. But listeners of the podcast can get a discount, 20% off, using the coupon code RUD23. RUD23. That's RUD23. Podcast listeners get 20% off the Starship rocket pen. And we put it up on Etsy because it simplifies a lot of the stuff, especially for our viewers who are around the world and shipping can be difficult. Etsy's helping make that possible. So go check that out. And yeah, thanks for supporting the podcast. As always, AG3D Printing, our lab is open if you have any projects that you'd like to work on, anything you'd like designed. We've got over a decade of CAD experience, so we can help literally bring ideas into reality from a piece, a drawing on a napkin, or, you know, if you have a model and you want to get something 3D printed, or you're just looking to see what's possible. So ag3dprinting.etsy.com, Starship Rocket Pen. Go check that out. Now, this week, we had an incredibly amazing opportunity to go speak with Avi Loeb for the second time, and he graciously invited me over his house. He is over at Harvard, and, you know, I went and got to visit the man himself, and it was a great interview. He just came back from this expedition to look for evidence of molten material of an object that, according and confirmed by the U.S. Space Command, up to 99.999% confidence, that the speed that it was coming in indicates that it was not bound to our sun, which would imply that it came from out of our solar system. So he designed an experiment. He'll go through all of this. His new book, Interstellar, that's coming out, is going to be about that, and it's going to describe this. And he gives a great breakdown of everything that's happened since the last time we had him on the podcast, when his last book, Extraterrestrial, came out. We were discussing Oumuamua, another interstellar traveler that came through the solar system. Avi is trying to create experiments that can be tested through the Galileo Project by going to these expeditions. IM1, which is this object that was seen to have come in through the atmosphere in Papua New Guinea, and they designed an experiment around known physics to say, if it were something that is from another intelligent species out there in the universe, whether they're operating it or whether maybe the scale of time, maybe they were big at one time and they don't exist anymore, there might be space trash. And so going on that concept, they designed an experiment, used IM1 as an example. They said, well, if it went through the atmosphere, this metallic, these droplets, Spherules of material would have come off. What if our New Horizons spacecraft one day, or Voyager one day, it's 10,000 years and it finally happens to end up in the orbital path of another planet and goes in through its atmosphere? What would we find? The molten material might represent technology. So their experiment was, let's estimate where those spherules would be. Let's bring something out to the ocean and bring up those, what would be magnetic materials. Let's bring them up and investigate them and see what they're made of. and they're back, and they found Spherules, and I was going to tell you all about it. So it was a great episode. Thank you, Avi, for being kind enough and gracious enough to allow me in your home and to give you a platform to share this and for us to discuss some of the more curious nature of science and still doing good science so that we can learn more about reality in the world around us. So make sure to buckle up and get ready for this one. It was a great episode. Avi's book will be out soon, Interstellar, so go check that out. And that's it, folks. So thanks for joining us for Today in Space. As always, be well, spread love, and spread science, and enjoy our conversation with Avi Loeb. Welcome, everybody, to another episode of Today in Space. Today is July 16th, 54 years ago. Today is the launch of Apollo 11. So it's a historic day, and we're very lucky to be in the presence of Avi Loeb, his second time on the podcast. So thank you very much for being on.
Thanks for having me, Alex.
Absolutely. So we have a lot to talk about. The last time we spoke was when your last book had come out, Extraterrestrial. We were talking about Oumuamua and the importance of asking questions and experimenting against the truth that we see in life.
And here we are, 3,000 interviews after that.
Yeah, you've been very busy. So tell us a little bit about your latest adventure, searching for IM1 and the Galileo Project. I'm sure folks would like to know what you've been up to since then.
Well, it all started with the discovery of Oumuamua back in October 19, 2017. And I did not work on objects near Earth in the solar system. Prior to that, I just wrote a paper about the abundance of interstellar objects based on what we know in the solar system. And frankly, the paper just said that the Pan-STARRS telescope in Hawaii will not find any of those based on what we know about the solar system. And then when they found Oumuamua, that was a surprise to me because we predicted that by several orders of magnitude it would miss the opportunity to discover any such object. And that was puzzling. Why did we get it so wrong? Okay, because in science very often if you get something wrong, it's an opportunity to learn something new. And in the process of doing so, I was also informed that this object appears to be quite unusual. It was flat in its shape, just like this 3D printed version that you made. And most recently, I suggested that this flat shape could be because it's a piece of a broken Dyson sphere. You know, Dyson spheres are thought to be megastructures constructed by advanced civilizations around their host star to harvest more of the light from the star. And it's really difficult to make them stiff and as a solid piece. It's much easier to make them as tiles that are hovering above the star and are held against gravity by radiation pressure. The radiation from the star is balancing gravity, so they just like a kite, they are hovering.
Yeah, against the wind,
And if you have many such pieces overlapping, they can extract a lot of the energy radiated by the star. So it occurred to me that after a few billion years, such a structure would basically be destroyed by asteroids impacting it unless you maintain it. But it's hard to imagine civilization that keeps maintaining it for so long. But also the star itself would evolve and produce much more radiation than most of its life. And at the end phase, it just expands and then radiates much more. And so as a result, this system of tiles will get expelled from the system, from the planetary system.
Right.
And it's very easy for those tiles to escape the pull of gravity because already they were in a neutral state where gravity didn't play an attractive role because it was balanced by radiation pressure. So once the star evolves, you break up those, and the pieces from the broken Dyson sphere could be like Oumuamua was, basically a dysfunctional entity that is not operating. It's not a functional device, but you can still tell that it's thin, like a membrane, because it's being pushed by reflecting sunlight. And that's a possibility. Also, it could be the surface layer of a bigger object, like a spacecraft. Anyway, I suggested that the push that this object, Oumuamua, exhibited was the result of reflecting sunlight, because we didn't see any cometary tail around it. Right. And then 3 years later, the same telescope in Hawaii, PanSTARRS, discovered another object. This one was clearly pushed by reflecting sunlight and didn't have a cometary tail, no evaporation, just like Oumuamua. And a few weeks later, the astronomers realized, actually, this one we can explain, because if we go back in time, it came from Earth. It was orbiting around Earth.
Right.
And it was given the name 2020 SO and turned out to be a rocket booster from a 1966 launch by NASA. So here we have it, a technological relic that we produced and became space trash.
Right.
The question is, who produced Oumuamua? And it was in my mind, 2 years later, a year and a half later, I was interviewed in January 2019 about a meteor that exploded above the Bering Sea near Kamchatka. And in preparing for this radio interview, I looked online and found this catalog of meteors that NASA compiles. There were 273 meteors in it, right. And they gave velocity information about each of them, measured by the US government setup of satellites, ground-based sensors, and so forth.
National defense type of things.
Yeah, exactly. That the US government uses that to monitor for ballistic missiles and that are a national security risk. So you would expect them to be quite precise.
I hope so.
Well, we hope so, but some astronomers just last week published a paper saying, no, we don't believe the US government, and they must have made a mistake by a factor of 3 in the measurement of the speed of meteors, in particular the one that we'll talk about in a minute.
Absolutely.
And I thought to myself, how do they sleep well at night? Because imagine a ballistic missile, the US government, if it's wrong by a factor of 3, would alert Mexico about the missile when it's headed towards Washington, D.C. or something like that. I mean, factor of 3 is a huge factor.
That's a lot.
So anyway, I asked my student, undergraduate student at the time, Amir Siraj, to go through the catalog and look for the fastest moving meteorites. We don't know. These are objects that collided with Earth, and perhaps there is one that came from outside the solar system if its speed exceeds the escape speed from the sun. And that is easy to calculate. Basically, you know when the meteor impacted Earth, you know the motion, the velocity of the Earth at that time, and you know the velocity of the meteor relative to Earth. So you just connect the dots and figure out the velocity of the meteor relative to the sun. And if it's bigger than the escape speed at the vicinity of Earth from the solar system, then you know it came from outside because it's not bound by the gravity of the sun. So he went through the fastest moving objects and found that the second one indeed is a very good candidate. And that was, we termed it later on, I came up with the terminology IM1 because it's the first interstellar meteor. It was discovered by the US government on January 8th, 2014, so almost a decade ago. And it basically exploded in the lower atmosphere of Earth, about 20 kilometers over the Pacific Ocean, and 90 kilometers away from Papua New Guinea, Manus Island. And we wrote a paper about it saying this may be the first interstellar meteor. And my colleagues, the referees, there were a number of referees, said, no, we don't believe the US government. It could be wrong because they don't tell us which instruments they used and what is the precision of those measurements. So I was at the time chair of the board on physics and astronomy for the National Academies, and I was frustrated, so I mentioned it at a dinner talk, and then someone from a member of the committee from Los Alamos volunteered to help, and eventually it was someone at the Office of Science and Technology Policy at the White House that reached out to the US Space Command and it took them 3 years after our paper was rejected from publication. So
Wow.
in March 2022, 3 years later, they came with an official letter to NASA, the science division of NASA, saying that they checked the data, and at the 99.999% confidence, they confirmed the interstellar origin
Wow.
of this object, meaning our velocity measurements are very precise. Okay, so we resubmitted our paper, and eventually, after some adjustments, it was accepted for publication. And then the government also released data about the fireball of this object, because it released a few percent of the Hiroshima atomic bomb energy by the friction with the air. And that explosion had 3 flares, and we were able, from the location, to infer that this object was able to maintain its integrity under much more stress than all 272 other meteors in the catalog of NASA.
Wow.
So
a lot more robust of an item
it
that
must
came
be
in.
made of materials that are tougher than even iron meteorites.
Wow.
And those iron meteorites make up only 5% of all space rocks. So the question is, what is it made of? And we also calculated that outside of the solar system, it was moving at 60 kilometers per second. Not only it was unbound to the sun, but relative to the local frame of the Milky Way galaxy, which is called the local standard of rest, this object was moving at 60 kilometers per second, meaning faster than 95% of all stars in the vicinity of the sun. So it was a fast mover relative to stars near the sun. And so the question is, if it's moving fast and it's made of materials that are tougher than iron meteorites, could it be a technological object, a spacecraft that may be dysfunctional, just like Voyager will be once it exits the solar system in 10,000 years.
Right.
But you can tell that it's technological. If Voyager would collide with an exoplanet, it would burn up as a meteor if the planet has an atmosphere like the Earth. And
Right.
you would notice that it's made of materials that are different than stones or rocks. And at that point, I decided to lead an expedition to find the materials from this object. And so a few months later, there was a donor that contacted me, Charles Hoskinson, and he arranged a Zoom call with me and said, you have the money, $1.5 million for this expedition. And I assembled a team of highly qualified professionals, the best in the world for ocean expeditions. And the coordinator was Rob McCallum, who is has a lot of experience organizing such missions. And what we did is build a sled, which is basically something we dragged on the ocean floor with a cable connected to the ship.
And the ship called the Silver Star.
Exactly.
And it's a completely aluminum ship, from what I understood.
Made of aluminum, and it has this name, which is very fittingly associated with this expedition. And it had a very large deck, and I used to jog on it every morning, as I do at sunrise. And one of the mornings, the filming crew that came with me, there were 50 filmmakers and producers that wanted to be on the ship, and I chose just one.
Wow.
And that filming crew decided to film me jogging, and the director asked me, it looks like you are running. Are you running away from something or towards something? And I said both. I'm running away from my colleagues in academia who have strong opinions without seeking evidence, and I'm running towards a higher intelligence in interstellar space. And so that basically encapsulates so what we did was drag this sled on the ocean floor. It was covered with magnets on both sides. And the goal was to collect magnetic particles that may have been, for example, melted off the surface of the object when it was exposed to the immense heat from the fireball. We were able to localize the meteor path to within a kilometer by using the signal that was received by seismometer in Manus Island. That was the sonic boom, the blast wave resulting from the explosion that had some time delay arriving to the seismometer relative to the flash of light. And from that time delay, knowing the speed of sound, we could tell how far away the explosion was and figure out the path. And then we went there and tried in the first 2 days, tried to get the sled to stay on the floor of the ocean, which was 2 kilometers deep. And that was a major challenge because the ship would move differently than the sled, being subjected to different currents, ocean currents. But we eventually, the amazing engineers on the ship, found a way of following the ocean currents such that the sled would stay on the floor. So after the first 2 days, we started collecting materials from the bottom of the ocean, and most of it was volcanic ash. You can see it here in this vial. This is from the last run number 26. We had 26 lines, each of them 10 kilometers long, where the sled that is 1 meter wide was dragged on the ocean floor. So in the last one, we just didn't have time to go through the materials because we had to pack just an hour later. So but what we did was collect, basically scrap the magnets, and most of the material was black powder. So after 6 days, I thought, what is going on here? We haven't found yet the spherules from the meteorite. And spherules are basically the molten droplets from the surface of the object. And a day later, what we did was use a mesh with a size that is 1/4 of a millimeter to filter out all the small particles of the black powder, the volcanic ash. And those particles were less than 1/4 of a millimeter, so they went through the holes of the mesh, and then whatever was left, we dried up and put under a microscope. And I still remember that the geologist of the team, Jeff Wynn, running down the stairs to call me, saying, we saw the first spherule on the image, the digital image from the microscope. And I went there and hugged the person who saw it first, Ryan Weed, who was looking through the sample. And it was obvious to me that, from the experience of being in the kitchen and looking at the small area and finding an ant, you immediately know that there must be a lot of ants out there if you see one.
Had this happen to me earlier this year.
And so, sure enough, within hours, we found many more spherules, altogether 50 on the ship. But now that we came back, I have an undergraduate summer intern named Sophie Bergstrom, and she just yesterday went through a little more material, and she found 10 more. And so we have more spherules, and I'm sure we'll find hundreds. Because when we looked through the microscope, we saw a lot of small ones that we couldn't pick up with tweezers.
They were that small.
We used to pick them up with tweezers and put them in a vial, and they're tiny. And if you look at them through a microscope, they look beautiful. They are just like metallic marbles. My daughter asked me to put one on a necklace for her, but I said it's too small to thread. They are all between a tenth of a millimeter to a millimeter in size. So they're really tiny, roughly a milligram in mass. So we collected of the order of 50 milligrams of valuable materials from this meteor, we hope. I mean, some of it could be other meteors, but we will be able to tell by now studying, doing analysis of the composition of these spherules.
It was a really amazing story to follow online. You were journaling on Medium, and I was keeping in touch. How many people were following along?
Millions of people. I didn't anticipate that. I wrote 38 reports, diary reports by now, and it was translated to Spanish. And I got all kinds of emails from people that suggested that they were inspired by this. And one of them said, I had a stroke just a few weeks ago, and this reading your essays gave me strength to live. the bottom line is science could be exciting if it resonates with the interests of the public. And very often scientists remove themselves from the public. They contact the public with the final findings in the context of a press conference where they lecture to the public what the findings are, because they don't want to expose any uncertainty, any mistakes that were made along the way, because they're worried that the funding will go down, and they portray a much better image. It's just like putting makeup, you look better. But the point is that the public then gets the sense that science is an occupation of the elite that tries to show off, to demonstrate that it's smarter, while in reality, we are all humans. And when presented with evidence, we'll come up with conjectures, and then we might be wrong, and then figure out the truth by getting more evidence. And that's exactly the scientific process. So a lot of people told me for the first time, they could see how it's done. And for example, one day the sled came back with white paint on it, and it looked like a Jackson Pollock painting, a splash of white. And I thought, it must be a bucket of white paint that a sailor dropped off a ship and sank to the bottom of the ocean, and we just bumped into it with a sled. I mean, that's a reasonable thing to imagine. And then, nevertheless, I swiped my finger through this paint and put it in a vial. We took it to the X-ray fluorescence analyzer to check the composition, and found that it's biological, actually. And then found online that there is this gooey stuff at the bottom of the ocean that if you bump into it, you can be painted white.
Oh, wow.
So that shows you how we work. Basically, I made a mistake, nothing personal. I just thought it's reasonable, and it sounds reasonable, but then you go and check, and it's incorrect. So you just recalculate, just the way the GPS system does. And the whole point about doing science is that it's a learning experience, and we should be modest. But instead, scientists portray an image where they know the answer, the final finding is the message they deliver, and they don't show the weakness of science, sometimes not being sure of the answer, having a conjecture that turns out to be wrong. A lot of scientists actually are very happy, these are theoretical physicists, very happy to work on a subject that will never be tested experimentally in their lifetime, such as the existence of extra dimensions or the existence of the multiverse. Why are they happy? Because they would never be proven wrong. And in my view, they should not be happy about it, because they will not learn anything new by not being tested experimentally. Either their ideas are right or they are wrong. Okay, these are the two possibilities.
Binary,
So if they are right, it would be very rewarding to get an experimental test that will demonstrate it. But if there is no test, we never know. So they are not getting the reward they deserve. But then if they are wrong, they are wasting their life on an idea that could be useful for mathematics, but is not really physics. I mean, it's, you can say, okay, but what's bad about that? Well, you shouldn't call yourself a plumber if all you're doing is write books, that if your profession is defined by the fact that you fix the toilets and the problems with that relate to plumbing, that's your definition, right? So you can't pretend to be a plumber while you just keep typing all the time books, like theoretical ideas. Or you can argue that you're a plumber in the metaverse, and for that one needs to put goggles on our head, just like you can argue we live in extra dimensions. You just need to imagine that. But that's not really physics, okay? That is that is a business model for Mark Zuckerberg, okay, to put goggles on the heads of people so that they imagine something that doesn't exist. The idea of physics is to find what the reality that we live in, that all of us share, is, okay? Why is it important? Because if we kept thinking that the Earth is at the center of the universe, like people advocated for thousands of years, including Aristotle, if we were to think that, and we wanted to reach Mars, we would never get there. Why? Because we would argue that Mars must be orbiting the Earth, if the Earth is at the center of the universe.
Right.
And then we would send all these rockets and they would never get there because Mars is not orbiting the Earth, okay?
Right, right.
So us knowing what the reality is, and if on the one hand it makes us modest, right? Because we are not at the center of the universe, therefore we shouldn't feel privileged. And that's one aspect of modesty. But the second is to let reality tell us what it is, rather than have it in our mind and insist and put Galileo in house arrest just because he claimed otherwise. So you would think that after 4 centuries, scientists who define themselves, their job is to figure out reality. That's their job. Yet, many of them decide to focus on things that cannot be tested, even in their lifetime. I'm not talking about tested next year, a decade. It's not even clear that we would ever test it. They're happy to do that. A group of thousands of practitioners. I'm not talking about a small group of people that decided to deviate from the beaten path. This is the beaten path of theoretical physics for 4 decades. Okay? So that is defined by people who call themselves physicists without subjecting their ideas to the guillotine of experiments.
Yes, of the gauntlet of the scientific process.
So that exists on the one hand.
Yeah.
At the same time, there are objects we see in the sky, okay? And they look strange. They don't look like the rocks we see in the solar system, suggesting that they are like Voyager, Pioneer, New Horizons that we sent to interstellar space, like space trash, suggesting that such things may exist just because other civilizations formed before us, just because we know that most stars formed billions of years before the sun, just because we know that a significant fraction, more than a few percent of those stars, have a planet the size of the Earth, roughly the same separation. It sounds like common sense to say, wait a minute, we are here, someone else might have been there. Sure. This is not an extraordinary claim to say maybe there is some space trash associated with their Voyagers, New Horizons, Pioneers, because these gadgets will not be functional in a few billion years when they reach another planet.
Right.
And so when we see things around us, we should check
Absolutely.
whether that seems to be heresy. That appears to be outside of the mainstream. That is a subject to attack me personally for investigating, even though I'm following the scientific method. So when I left on the trip, just a week before I left to the expedition, a colleague of mine approached me and said, many of us think that you will not find anything, that it's a waste of money, and why would you do that? And I said to him, I'm not asking you to do anything. You just sit back and relax. I'm doing the heavy lifting here.
Right.
I'm using money that was not allocated to your dark matter research.
It's not taking away from anything.
Not taking away. You can continue to work on weakly interacting massive particles as the dark matter, even though for 40 years we haven't seen anything. You can keep investing billions of dollars in the search for those particles, even though we haven't found anything, which is actually happening, right? So people have conjectures about what the dark matter might be. We're talking about matter that we didn't find in the solar system, okay? And just think about this. When the interstellar meteor was measured by the US government sensors to be interstellar, and there was this letter, a year later, after this letter from the US Space Command was issued to NASA, a year later, there is a paper published in the Astrophysical Journal just on the day that I come back from the expedition by 2 experts on space rocks saying, we cannot fit the data with our model for stony meteorites. Therefore, the data must be wrong. And the government is off by a factor of 3 in the velocity measurement. And
a lot to be off by.
And moreover, this object cannot be made of iron. And that's at the time that I was holding in my hands the spherules from the meteor site, and knowing that they're made mostly of iron based on the X-ray fluorescence analyzer on the ship. They're saying they're not iron. I could sleep better at night because I know the US government sensors got the right answer because I went to the site of the meteor and I found it. I found the spherules there. And moreover, I know it's made of iron primarily, but then there are additional elements. It could still be an alloy, artificial alloy. And my question is, when you have data that indicates something is unusual, okay, and it's exquisite data according to the government, I believe them because, you know, they are supposed to find ballistic missiles.
Right.
And then I go to the place and find the evidence. Why would that be a problem to some people who portray themselves as scientists when they are supposed to be guided by evidence? While there is a whole other community of scientists not even seeking evidence for decades regarding what they do.
Right.
So something is wrong in the way that scientists are thinking about science. It's not about showing off. It's not about maintaining past knowledge by insisting that everything in the sky must be stony rocks.
Right.
It's not about that. It's about looking for things that do not look like stony rocks and asking, could they be something else? Why is that so difficult?
Yeah.
And if the evidence is intriguing, we should collect more evidence to figure it out. So going to an expedition makes a lot of sense. I'm just trying to seek more evidence.
Yeah.
Why would anyone have negative feelings? It's a win-win proposition.
Yeah.
If I don't find anything, you know, nothing was lost. If I do find something, we learn something new. So as a scientist, you can't call yourself a scientist if you are against someone else trying to retrieve evidence. Just think about the dark matter. We've been searching for evidence. We haven't found it, but searching for it. And if we were to follow the logic of these two astronomers that wrote the paper when I came back from the expedition, they would say, what we see in the solar system is ordinary matter. If we try to explain observations of cosmology data observed by cosmologists, if we try to explain it using ordinary matter, we cannot. Just like we cannot explain IM1 with stony meteorites from the solar system. Therefore, the data must be wrong.
Yeah.
Where would the entire field of cosmology be? After all, its main focus for 90 years has been what is the dark matter? So if we follow this logic, we would say there is no dark matter, the data is wrong. And of course, we can bury our head in the sand and just pretend as if everything is normal matter, which some people try, but it's not really the main view right now. So the only way for us to learn something new is to allow ourselves for our models to be wrong.
Yeah.
Right? So in order to learn something new, you have the model to be wrong because the model encapsulates past data. And so I use this expedition as a teaching moment for my colleagues in academia, but also as a teaching moment for the public so that the public can see how science is supposed to be done. And I'm really surprised that this is not folklore, that this is not like people would say, of course, all of us agree on that. Like, no, instead it becomes controversial. Why should that be controversial?
I don't know. The way the world is today, I'm not surprised that it's controversial. But, you know, personally, so I work in engineering. So, and on the bleeding edge of technology. So for me, I never have a foot to stand on to step back and say, well, that's what we know, because usually I'm the first person to try and figure it out. So I am very much, and maybe engineers are the black magic of the scientific community, but, you know, we don't have the luxury of time to sit around and contemplate, especially when you have a customer.
Right.
That is your rubber meets the road. So I think, in some ways, we're lucky.
But in academia, it's a completely different ballgame. I mean, the whole idea of tenure is to allow you to deviate from the beaten path and examine possibilities that people with, financial pressure cannot. So
I had never heard it described that way. That's cool.
So the tenure, the concept of tenure is such that you have job security and you don't worry about your job. If you were to explore something that is not popular at the moment. And obviously you're not aware of that because most of the practitioners are using tenure as a vehicle to gain stature or honors, awards, but not really to take the path not taken. And, to me, this particular path should have been taken by many a long time ago because it's of great interest to the public. More than 2/3 of Americans believe in extraterrestrial intelligence. Okay, so you want science to resonate with the public. It doesn't need, there is no point in distancing science because science should reflect the interests of society, okay? And moreover, you want science to be guided by evidence.
Yeah.
And putting these together implies that this is an ideal subject where we can, approach it differently than we did for 70 years, which was looking for a radio signal or electromagnetic signal. It's just like waiting for a phone call at home.
Yeah.
Nobody may call you because it requires someone to be active and to know your number.
Right.
But you might, if you go out to your backyard and you look around, there might be some objects that came from the street that are not the familiar rocks that you always see in your backyard.
Right.
And it could be a tennis ball thrown by a neighbor. And we just need to open our mind to learning about the cosmic street by just looking for physical objects in our backyard, which is not very complicated. I find that common sense is not common.
No. And I think we're lucky that we live, especially since the last time we spoke, I think a lot has changed. The public discussion of being curious about what's out there is at a level that I don't think it's been since maybe I was a child in the 90s.
Right. I hope I had some role in this.
Definitely. I got a new telescope because of you. So since the last time, because having eyes on the sky, and I was able to capture that supernova in the Whirlpool Galaxy, and that was because of you. So thank you.
Thank you.
We live in a time where we have James Webb Space Telescope,
Right.
which after a year is going to be rewriting those books.
Right.
Because we're finally seeing the evidence.
So I wrote some of these books about
Really?
the first galaxies. Yes, I have two of them. And indeed, the Webb telescope is finding new things about the first galaxies that are not... And I'm very happy about it. I always said that I would be happy to update my textbook about the first galaxies rather than just write new editions and be happy that the Webb telescope confirms what we expected, because then it represents new knowledge. And so we have some new knowledge from the Webb telescope. The Webb telescope could also be helpful for interstellar objects, because if it looks at an interstellar object, it can not only see the reflection of sunlight from it, but also detect the infrared heat that is emitted by the object. And that helps us in terms of, we know we can calculate the surface temperature of the object based on its distance from the sun. And detecting the emission of heat from the object allows us to figure out its actual size and distance very accurately, and infer the reflectance of sunlight from it as well. And so much better than what was done without the Webb telescope.
Right.
And moreover, it's a second eye because it's 1 million miles away from Earth. So if you use the telescope on Earth and the Webb telescope, you can triangulate and basically get a distance estimate that is very precise. And it's the same reason that we have two eyes, and they allow us to identify the distance of a threat. And that's why people with two eyes survived better than people with one eye, or whatever our ancestor was.
Right.
So anyway, altogether the Webb telescope brings a lot of new opportunities for the study of interstellar objects as well.
Yeah.
And not just and these are the nearest objects to Earth that come from far away, whereas the farthest galaxies are, the earliest that formed in the universe, and that's what is usually talked about in the context of the Webb telescope.
Yeah, and I think, so it's a great example of getting data and actually observing reality, and how much we've just learned in a year. I think what you are doing with this trip, it's again another thing, and I don't think that orthodoxy of any ideal, whether it's religious or scientific, whatever it is, it doesn't open you up for curiosity.
Right.
And I think it takes trips like this to go out there to get data. And not only that, you're doing it in a way that connects more with humans than, I think.
Well, I feel that I grew up on a farm. I don't feel in any way different than anyone else. When I was taken on a private jet of the donor on our way to Papua New Guinea, and as I entered the plane, pilot said, "Welcome aboard, Professor Loeb." And he must have read things about me. I've never met him. And I said, titles are irrelevant here. You can call me Avi. I'm just a curious farm boy. That's why I'm here.
Yeah.
And that defines me. Now, interestingly, I got messages from 2 rabbis who were inspired by my writing to deliver a sermon for the Jewish high holidays. I received just this week an email from a sculptor who is planning to make a sculpture to celebrate my research.
Wow, cool.
I received an email from a playwright who just finished a play that he hopes will be presented on Broadway about my scientific career.
Cool.
I received a letter right here from a songwriter who received 2 Oscars, 3 Grammys, 4 Emmys, and 3 Golden Globes for his songs. And
wow.
He is writing a song about my scientific career. And so altogether, it's really amazing to see artists coming forward and volunteering support for what I'm doing. I think the reason is simple, that when you are studying the unknown, it resonates with people who are engaged with spirituality, with art, because they are also creating something new. And they fully understand how difficult it is.
Yeah.
But somehow, the public at large is extremely enthusiastic. I get huge number of messages every day. Government is very enthusiastic about what I'm doing. They came to my home several times. They send me supporting messages, and they are also in support of the Galileo Project, which has other components to it.
Yeah, could you describe the Galileo Project a little bit?
Yeah, so it came about 6 months after my book Extraterrestrial came out, when a few multi-billionaires visited the porch of my home and said, "We are inspired by your vision. Here is the money for you to follow research on this subject." And together with Frank Laukian, one of them, we co-founded the Galileo Project. And basically the goal is to look for objects near Earth that may have originated from a technological civilization far away. And it has 3 branches. So one of them is the expeditions of the type that I described, that we just took. And now we are analyzing the Spherules to find out if this object was from outside the solar system and based on its composition, but also whether it was technological in origin based on the composition. You can tell, if you melt semiconductors or computer screens, they would produce droplets that have a different composition than rocks.
Right.
So that's one branch. The second branch of the Galileo Project is to look for objects like Oumuamua, more of them with the Rubin Observatory, and study them with the Webb telescope and other, and perhaps even rendezvous with them in a space mission.
That would be amazing.
And the third project, the third component of the project, is looking for unidentified anomalous phenomena that the US government talks about. They cannot figure it out.
Yep.
There is a new office in government, in the Pentagon, called the All Anomaly Resolution Office, AARO.
AARO, yep.
And together with the director of AARO, who visited my home, we actually wrote a short paper together. And they would like to understand what these anomalous phenomena are, and they're doing their best based on data that they have access to within the government.
Right.
But the Galileo Project is basically saying the sky is not classified, right? It's only the government sensors. And that's why the data that the government owns is classified, because it was collected by sensors that the government doesn't want adversaries to be aware of. So
which makes sense.
That makes a lot of sense.
It does.
I don't like to push the government. I don't believe there is any conspiracy around it. It's just that it's because of national security concerns, they have to hold on to some data. But instead of asking them to do that, we are trying to collect even better data. So the thing about the reports on UAP in the past, unidentified anomalous phenomena, is that they were anecdotal. Someone happened to be at a place at some time and saw something. So we want to make it systematic. In other words, we built an observatory at Harvard University that is already functioning.
Oh, wow.
That monitors the sky 24/7 in the infrared mainly, but also in the optical, radio, and audio. And then we are analyzing the data that we get with machine learning algorithms that try to identify objects, whether they are natural, like birds or bugs, whether they are technological, made by humans, like balloons, drones, airplanes, or whether they might be something else from outside of this Earth. And even if 1 in 1,000 objects looks like it's extremely unusual, that would be an amazing find for science. And of course, the government may have already some data, they may have some materials, but we haven't seen that evidence. So I don't know what to say about it. People talk about it, but it's not the same as having the evidence.
Yeah, it's true.
I mean, people can talk about many things. They can even decide that they are Napoleon, you know, but it doesn't make them Napoleon. So, so the fact that there are reports or people provide eyewitness testimonies is not sufficient for scientific analysis. And what we want is to use the best instruments and monitor the sky systematically, so then we can tell how many background events there are. The statistics is better calibrated. If you find an unusual object after looking for it over a certain period of time, you know how rare it is. And so it helps a lot in figuring out what it might be.
Okay.
And also how abundant such things are.
Right. And one of the things that we had covered on the podcast, that UAP meeting, where the head of Arrow was there as well. And it seemed like a very, from someone working in STEM, it was about data, and everyone has that conversation. What is good data? What are the instruments? What are we really seeing? And where can those be wrong?
That is the NASA study.
That was, the NASA.
By the way, this NASA study was inspired by a white paper that I wrote to NASA 2 years ago, before the Galileo Project was established, just a month before. I approached NASA because Bill Nelson said publicly that he thinks scientists should get engaged with studying UAP. And immediately he said it on CNN. The following morning, I contacted Thomas Zurbuchen, who was the the head of the science directorate. And he said, why don't you send a white paper? I sent a white paper suggesting, and I haven't heard back. So then I established the Galileo Project. And then a year later, they announced this study. And I asked, why didn't you ask me to be involved in the study? And his office said, because you established the Galileo Project, so you're already engaged, you cannot be regarded as neutral on this subject. And then a year later, now, they're coming up with a report. What do they plan to say in the report? They already spoke about it. Basically the message of the Galileo Project. So you ask, okay, well, imitation is the sincerest form of flattery.
Absolutely,
that's what Oscar Wilde said, and I don't have any issue. It's just that they're coming to the same conclusion that I came 2 years ago.
Yeah.
In establishing the Galileo Project.
It would be better, I mean, you deal with this, anyone who works in a job, I mean, double work is never good if you can avoid it. If one project's doing the same thing as another project.
Well, they don't have a project. The committee is supposed to recommend whether NASA should invest in this subject. So they only spent $100,000 on the travel expenses of the committee members. That's pretty much it. But if they decide to fund it, of course I will compete for those funds. But the idea of getting better data is exactly what the Galileo Project has been doing for 2 years now.
So one of the things they were talking about, I guess, thinking about the big picture of moving this along so that everyone can get on the same page here, are those instruments that you're using, is it public knowledge?
Yeah.
What sensors?
We have 8 scientific papers that we published just a couple of months ago, and they can be found on the Galileo website, and we detail the kind of instruments we're using in some of them. So the idea of Galileo is we make the data and the methodology open to the public. it's a scientific project
Yeah.
where we share everything. We gave it to the committee, the NASA committee, so I'm sure, that their conclusions were influenced by reading our papers. Now, they may not acknowledge that for the same reason they didn't include me in the study, because they don't want to show any bias towards a particular individual or project. That's fine. But as I said, imitation is the sincerest form of flattery.
Absolutely.
And if you look at our papers and then look at their report, if you see similarities, our papers came first.
Now, I have a friend who has been following your work. Again, another person who's not actually involved in science. So definitely a big kudos to all the work that you're putting in. You're reaching people. So I get a lot of questions. The paper you did, I forget his name, but the head of Arrow right now.
Sean Kilpatrick.
Yes. So you guys did that paper together. What was the subject and what was the goal of that paper?
Well, it was very simple. Hypothetically, suppose we see unusual objects. How do we tell a human-made object from anything that may be from outside of this Earth, and what kind of scenarios we can imagine for devices that came from extraterrestrial civilizations? So we talked about, for example, a mothership releasing a lot of probes, some of which come close to Earth, and then measuring the distance based on the amount of heat released by the object. Just like a meteor, exactly the same approach. When an object moves through air, it heats it up and creates some radiation as a result, and you can infer its distance based on that, because if you make the distance too large, then it would imply a very high speed given the angular speed that the object has. So you can limit the distance. And in fact, I thought of this as a result of a bunch of Ukrainian astronomers who argue that they see dark objects in the sky of Ukraine during the past few years, and they said that these objects are the size of 10 meters at a distance of 10 kilometers, and they're moving at 15 kilometers up to 15 kilometers per second, which is above the escape speed from Earth. And I said to myself, they cannot be dark in that case, because they would create a huge fireball, just like meteors do.
Right.
I mean, if you want them to block light and be dark, they must interact with electromagnetism, because otherwise they won't block light. You can't make them dark relative to the sky without them interacting electromagnetically. Okay, so you say, okay, they interact electromagnetically. They must interact with the molecules of air, because those interact electromagnetically. So they will create a fireball. There is no way around it. You want it to be dark, it will interact with air. So as a result of that, you would get a fireball. This would not be dark if they are moving at 15 kilometers per second, the size of 10 meters, okay? So I wrote a paper just saying that. And I was attacked by people who say, oh yeah, you're applying known physics, but maybe there is new physics. And my answer to that is, no. To find new physics, you need exquisite measurements of distance. You can't say this is at a distance of 10 kilometers based on a very approximate method for figuring distance, because they use just one observatory. If they had triangulated, that's a different matter.
Right.
But they didn't. So I say, no, you cannot argue for new physics based on faulty data or assessment. So you have to use known physics until, you get exquisite data that leaves you no other option. And because physicists are trying to find new physics for decades, and you would get a Nobel Prize. And so you can't do that, okay?
Right.
And therefore I argued the distance must be much smaller, so they are not moving at 15 kilometers per second. For example, if you reduce the distance by a factor of 10, they would be moving at 1.5 kilometers per second, and they would be roughly a meter in size. These could be artillery shells. And where else would you find artillery shells other than Ukraine? Okay, and where else would they appear as dark things moving on the sky? And if you don't want them to be artillery shells, okay, you bring it another factor of 10 closer, then there would be bullets. Okay, so all I'm saying is, if you don't have a good distance measurement, don't argue for new physics, and don't say there are dark objects moving faster than the escape speed from Earth. Okay, because physics, as we know it, does not allow that.
Right.
And that's what we basically talk about in the paper with Sean Kirkpatrick about what known physics tells you. However, there is this folklore of people saying anything that we can't explain must be new physics. You know, the bar for that should be much higher, much taller than crappy data.
I like the way you think. I wonder how much of this is really people just being afraid to introduce new ideas to the world and then be criticized for them, which is why you're in science in the first place. That's like the...
Well, but the point of science is if there is an anomaly, you bring up possibilities, but you work within the known physics first. You are not pushing the laws of physics in order to explain data that is not exquisite, that is not beyond any reason. So when you argue for a distance, you have to have a robust distance estimator. You can't use an approximate distance estimator and then claim it's new physics. That is not allowed. So, you know, when I see Oumuamua as being unusual, I'm using known physics to try and explain it. I'm not inventing new physics.
Right.
When I see this meteor, I'm saying it's just made of materials like artificial alloys. It could be known physics that explains it. So this is not new physics.
No.
And saying new physics explains something is a very high bar because you need to argue that known physics cannot explain it.
Right.
Beyond any reasonable doubt, you can rule out a possible explanation based on known physics. And you know, that was true when dark matter was discovered, that, you know, from a variety of reasons, there was no way out using known physics. And so we said, okay, there must be a new type of particle maybe, or some matter, or some people say even, you know, maybe the gravity is modified, you know. But that's only when you have exquisite data and there is no way out.
And then that data would then lead you to the conclusion that there is a...
We are all happy to learn in that way. But if the data is not reliable, then we have to use known physics to imply what reliable data would have told us. Okay, and so that's the way the game is played. And so there are people, you know, out there who do not really follow that game, but that's the way science is done.
Yeah, absolutely. And you're doing something that I think many people who want to get into science actually envision when they first get into it, which is going on an expedition and actually like being involved with other people, which I know some scientists would not want that. What was it like? You enjoyed it. So tell me about the crew and the time.
And actually, I like two types of people. One that, you know, young people that don't have prejudice, they're not confined by the chains of groupthink. And but also I like people that are not necessarily professionals, that are, because they think freely and they don't want to show off. And there were lots of such people on the boat, on the ship. Many of them were professionals in ocean expeditions, but not in science, for example. And to me, that was a great company because we all worked together. Each person contributed, just like a basketball team. You know, I felt like we are all here, you know, to win this game, okay? And we are working together. So one person is better at one thing, another person at another, but all of us are pitching for the success of this mission. This is a great feeling that I remember from being young and doing sports with a lot of people. And, you know, in academia, it's a very different feeling. Because in academia, if you are just trying to win the game, that upsets a lot of other people. Yeah. And they will try to bring you down. Why? Because here is a flower. We don't want this flower to rise above the grass level. And because we are not part of that flower, and therefore this flower will never grow, step on it, until, you know, eventually it becomes impossible to avoid the conclusion of that, whatever different idea is.
Right.
But it's a very different feeling because I have to always struggle with others, whereas on the ship, I always enjoy the company of others working together towards a common goal. Yeah. And why can't science be that way? You know?
I would love for science to be that way more often. Do you have tools that you use to get yourself through the struggle that you have to go through in academia? Do you...
it's very simple. The tool is very simple. Avoid social media.
There you go.
I don't have any footprint. I don't care how many likes I get. So you see, when you want to move fast through air, you build an aerodynamic structure that reduces your cross-section for friction with air, right? So in much the same way, you reduce your cross-section for friction with people when you don't go to social media. And then not whatever they say there doesn't impact me because I'm not there. So I don't have any cross-section for them to damage me in one way or another. I just need my academic freedom. I have a group of young people that works with me very happily, and nothing more. That's the most genuine feeling of doing science. And I used to be the chair of the astronomy department at Harvard for 9 years, the longest serving chair, 3 terms. I was the founding director of the Black Hole Initiative. I'm still the director of the Institute for Theory and Computation at Harvard. So I played a lot of leadership roles, and they were simultaneous. I also am still the chair of the Breakthrough Starshot project to reach the nearest star within our lifetime with a spacecraft. So I know how the game is played. I've been part of the establishment, but a few years ago, both my parents passed away. That was around the time of Oumuamua being discovered, and I decided at that point to shift my attention from dancing to the tunes of others to doing what I think has substance and is important for the future of humanity. And that reflects itself in what I do now. Because we live for such a short time and we keep making attempts to please other people. And these are chains that basically prevent us from looking, beyond what we are consumed by, and looking beyond is really the path for discovery, And so I decided, after both my parents passed away, I said, the hell with it. I will just do what I think is the right thing to do, and not without trying to please other people. And of course, they're not happy about it because they would like young people not to behave this way, so that all the troops are in a line and they march along the beaten path. And one way to show to the troops that it's dangerous to do that is to beat whoever deviates, just as a sign. And I think that is very bad for innovation in science, because you want especially young people, to feel free, not to feel that it's a risk to their career, to innovate, to come up with new ideas, to question what is assumed by the paradigm, the mainstream. You want that to be part of the culture, but instead, there are these officers that make sure that all the troops are marching along the beaten path. And I'm trying to signal that no, science is better done differently, and I get a huge amount of support. So I would not exist otherwise.
I live in the world of social media because of my business. I've kind of separated. I don't really post for my own self. It's to get this message out there because it's a powerful tool, and I don't have the ability to be mobile yet. So traveling around isn't there. So I find what you're doing extremely exciting, and I'm glad to hear that you have a good
support system.
Because I can definitely imagine it being a tough road when your peers around you are always poo-pooing your really your existence, right? In some sense,
but at the same time, there are people with much more vision outside, and my hope is it will make a difference, that eventually everyone would come to the notion. And there is this metaphor that one can make with, there is only one bird that can pick on an eagle, and that's a crow. The crow picks on the neck of the eagle and tries to bite it. So the eagle, instead of dealing with the crow and responding to it, what it does is fly very high in the atmosphere, such that there will not be enough oxygen for the crow. And the crow just peels off the neck of the eagle. And so I see that as the best path forward. Initially, I was very irritated, and I tried to respond to others picking picking on me.
Yeah.
But now I decided to adopt the method of the eagle. I just go high enough and they will drop off.
That's beautiful. Any last words? Tell us about your book that's coming out soon.
Oh yeah, Interstellar. It's coming up in August 2023, and pre-orders are already possible. And
Awesome.
it discusses everything we talked about and more about the Galileo Project, about the expedition, and other things. And I highly recommend to anyone interested in this subject.
Well, we definitely highly recommend it. And Avi, thank you so much for being on the podcast for a second time.
My privilege. Thank you.
And best of luck to the rest of the findings that you find. And how many different individuals are going to be investigating what you brought back?
Oh, we have about a dozen researchers, but also there were 24 support people on the ship trying to help. And they deserve all the credit. So I put them on the paper as well.
That's great. I love that.
Because without them, we wouldn't succeed.
We
are all in the same boat.
We are, and I don't think there should be a wall between the scientists and people. I think
exactly.
I think the thought process of a scientific thought process. I think it's so important for a day like today. I find myself going back to the Stoics in the age of chaos that we live in, and it's given me a lot of relief and the ability to go through and to keep cutting through this. So.
Yeah, we are all on the same boat, and we call this boat Earth. So let's work together.
Absolutely. Well, thank you for joining me, everybody. Thank you very much for coming on another episode of Today in Space and following along. Where can folks find you right now, Avi?
Well, I have a column in medium.com, Avi Loeb at medium.com, where I publish every few days an essay about the things we discussed and give updates on the research. But also, you can find the book quite useful because it describes what I'm doing. And I have a web page at Harvard University that you can find and see some videos and other materials, papers, scientific papers that you might be interested in.
Awesome. It's been a pleasure having you. Thanks again.
Thanks for having me.
Spread love and spread science, folks. We'll see you on the next one. Have a good one.